Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello once again. Thank you for joining us on the Space Nuts podcast. My name is Andrew Dunkley, your host. Joining me, as always, is Professor Fred Watson, Astronomer-at-Large. Hello, Fred.
Hi, Andrew. How are you going?
I'm very well, sir. Very, very well indeed, aside from my continuing aching back. Don't pick up boxes is my recommendation, ever. I'm not going to do it for the rest of my life. But, yes, five trips to the chiropractor, and I'm still not quite 100%, but... yeah, that's what happens. The problem with getting older is you don't think about getting older and the way your body is starting to change, and you do things that you would have done in your 30s that you got away with that you no longer can get away with.
There you go. Well, you need to wear a badge that says, I cannot pick up boxes, so that when you say, I can't do that, people know why.
That might be a good T-shirt, actually, that one. Yes. But we press on regardless. Now, today we are going to talk about free-floating planets. They think there might be more of them than stars, actually. That's a lot of planets floating around out there doing their own thing. While we're talking about stars, which we weren't, but we are, we're going to talk about our sun because it might have been part of a binary system at some stage, which we have touched on before, but there may be some new evidence by the sound of it to perhaps confirm that theory. And our old mate, the Space Doogie, is back in the news. I'm so thrilled, because it sort of came and went and is never coming back again, to the best of our knowledge and belief. I was worried that it might fade away forever and we'd never be able to talk about it again, but here it is. And we're going to answer a question from Paul in Victoria, who wonders why we have never gone back to Uranus and Neptune since Voyager 2. The short answer, Paul, is that they had a committee meeting and they all decided that saying Uranus out loud was too embarrassing, so we're never going to go there again. I think they were all flushed with embarrassment over the name and decided that's just we can't put that on a media release, so we're never going back. We'll go somewhere else. That's my belief. I'm sure Fred's got another theory. We'll look into that. But first, Fred, let's talk about these free-floating planets, of which there appear to be many, many more than we might have originally considered.
That's correct. So these objects have got many different names, sometimes called rogue planets, sometimes called orphan planets. The name I like best is a slightly strange acronym which stands for Free Floating Planetary-Mass Objects. Okay, Free Floating Planetary-Mass Objects, which somehow becomes F-flops, or flops with a double F. And flops is a very appropriate name for them because that's what they are. They're not members of a solar system. They've somehow become disemboweled or disembodied.
They've gone, sod off, we don't want to be a part of your little spin out. We'll do our own thing. Thank you very much.
So these things are not just hypothetical. Excuse me. We know they exist. They are observed in some of the star-forming regions of our galaxy, most notably in the constellation of Orion, which, if I remember rightly, is where they were first found. And you might wonder how a planet that doesn't have a sun to light it up could shine. How could you detect them? And the answer is that planets of the order of Jupiter's size actually have low-level nuclear processes going on, actually specifically nuclear fission in their interiors, which generates enough heat that they are detectable in the infrared. In fact, Jupiter, if I remember rightly, emits almost twice the energy it receives from the sun because of these processes going on in its interior. So they do shine dimly in the infrared region of the spectrum. And that's how they have been found. We don't really know where they come from. And the two main theories are, first of all, that they represent a low mass byproduct of the formation of stars. So if you've got a cloud of gas and dust in which stars are forming, you're going to get stars of many different masses forming within that gas cloud, but you'll also get things that form because of gravitational, their self-gravitational attraction, that aren't big enough to become proper stars. We already know that there's a class of objects in that category which are very large in number. They're called brown dwarf stars, and they also shine by low-level nuclear processes. They are more than 13 times the mass of Jupiter, so they're quite big. But it's possible that, within that spectrum of masses of objects being formed within a gas cloud, you're going to get things that are planetary mass. And they're just the sort of last remnants, as it were, of star formation. That's one theory. The other theory is that they may well be planets that have indeed formed in a solar system, but because of the gravitational interactions between those planets in that embryonic solar system early in its life, that one of these things has got kicked out. It may even be possible that happened in our own solar system. We might have had an additional planet that got kicked out into a distant orbit. So that's the main thinking of where these things come from. What would help in all this?
Could it be both theories, though?
Yeah, it could be both. That's
happen
right.
both ways?
Exactly. You could get a different, you could disentangle. If you have observations of enough of them, you would probably be able to disentangle whether it's one or the other or both of those theories. So that's why the story is in the news, because some work that's been done at Ohio State University has looked at, the possibilities for these objects, and they suggest that they may be, as you said in the lead up to this, the headline, that these things might actually outnumber stars. There might be more of them than there are stars. And that kind of makes sense if they're, the sort of leftover debris of star formation, that you might have many, many gazillions of these things forming along with bigger stars, which we know about. But the question these authors pose is why would we, how could we find them if they're there, if these objects are so numerous? And they point to an upcoming NASA mission, which is due for launch, not yet. It's, I think, 2025 is when it will be launched. It has the name of the Nancy Grace Roman Space Telescope. Nancy Grace Roman, I think she's one of the brains behind the Hubble Space Telescope. She was a NASA luminary. In fact, she was NASA's first chief astronomer, and also, as I said, known as the mother of the Hubble telescope. So that telescope is a space telescope, and it has the potential to find large numbers of these objects. How can it do that? By the process of gravitational microlensing, which is that phenomenon that any gravitating object, whether it's a planet, a star, a galaxy, or a cluster of galaxies, distorts the space around it. And if you have, for example, a planet passing between ourselves and a distant star, you can see the distant star, but you can't see the planet. But what you can see is the effect of the planet's gravitational field on the light of the distant star. It actually peaks up the light into a signal. The light of the distant star gets brighter as the planet passes in front of it, which is completely counterintuitive. You'd think it would be the other way around, but in fact the gravitational field of the planet magnifies the light of the star beyond. And it turns out that the Nancy Grace Roman telescope is perfectly suited to observing this kind of phenomenon. We already do see gravitational microlensing of planets. That happens with ground-based telescopes. There's a number of projects that look for that. So it's not a wild guess that this would happen. We see it already. But if you can do it from space with the kind of accuracy that this telescope will have, you're going to find more. That's the bottom line. And the more we know about these things, the more interesting they will become.
Okay, so they're not part of a solar system. They're not orbiting a star. They've, for some reason, been ejected or formed in a situation where there wasn't an adequate enough star to orbit. So they've floated off somewhere. Are they all sort of within galaxy clusters, or are they or within galaxies, or are they perhaps floating between galaxies?
Good question.
Or a bit of everything.
So that certainly the ones that have been detected are all within our galaxy, because they, you need to be able to observe a star beyond them in order to detect them. It's the light of that distant star that you're seeing changing. And so they're all within our galaxy and in a sense relatively local, because our galaxy is a very dusty place. So even when we look at the Milky Way, we're only seeing stars 1,000 light years or so away, compared with the 25,000 light years that it is to the center of our galaxy. So they'll be in our galaxy. The ones that have been discovered so far, I think there are some that have been found away from star-forming regions, but I'm not sure about that. Certainly the ones that were first discovered were within star-forming regions.
Okay. We do know that there are objects that cross the galactic threshold, if I can use that term, and Oumuamua is one of those. It came from a different place. So I'm guessing these planets can do the same thing, or could potentially.
Well, that's right. I guess in an extreme case, you could have one barging into our own solar system from a very distant solar system. Hasn't happened yet, as far as we know.
Okay, but the theory is there might be a heck of a lot of them, and they could be all sorts of shapes and sizes too, I imagine.
They will not, however, we believe, account for the dark, the idea of dark matter.
Someone was going to ask that, and it was going to be me, but I can imagine. They're just, again, probably just a minuscule part of the entire makeup of the universe.
Yeah, when you look at the amount of mass that they would contribute, even if they are outnumbered stars, the amount of mass they contribute is nowhere near enough to make up the dark matter.
Okay,
but
they're out there. Yeah, well, we've been doing this for so long. I guess that just sort of happens sometimes, Fred.
Yeah.
But they're interesting, and who knows? We might get a visit from one day. Although that could be catastrophic if it's sort of headed straight at us.
Yeah,
we don't really want that.
No, we don't want that.
No. And I suppose even though the last time we spoke about it, the theory was starting to be considered that Planet 9 does not exist, could Planet 9 be a free floater?
Well, we're about to talk about that in our next story, actually, Andrew.
Oh, okay. Oh, all right. Well, I'll put that on hold for the moment.
For about a minute and a half, yeah.
Indeed. You're listening to the Space Nuts podcast with Andrew Dunkley and Fred Watson.
0G, and I feel fine.
Space Nuts.
As always, I'd like to say thank you to our patrons, and there are many ways you can support the Space Nuts podcast. You can do that through patreon.com and sign up to pay voluntarily, of course, to support this podcast. There's also Supercast. It's spacenuts.supercast.tech. You can do a free trial for 30 days, and if you don't like it, well, you can give it up or you can keep going. There are various price structures within Supercast, so we have combo deals as well, so you can listen to multiple podcasts depending on what kind of fee you want to sign up for on Supercast. Another way of supporting us is to listen via YouTube, because the magic number on YouTube is 4,000. If we can achieve 4,000 downloads a week on YouTube, that benefits the podcast financially as well. So there are many ways you can support the podcast. I'm not going to tell you what you should or shouldn't do. It is purely up to you. It is totally voluntary. And if you're happy doing what you're doing, then I'm not going to tell you to change that. But as a patron, you do get bonus material and you do get the ad-free version of Space Nuts. Just saying. Now, Fred, let's move along. We hinted at this a moment ago, but our sun may have had a twin, or it may have been part of a binary system. Now, we've talked about binary stars before, and they're not that uncommon, as it turns out. But our sun sits alone, but he or she or it may not have in the past.
Exactly. And one of the reasons why this idea keeps cropping up is that we know when we study sun-like stars throughout the galaxy, a lot of them have binary companions, so that they start their life as a pair of stars. And in fact, it may even be that most of them started their lives with binary companions. And so if that's the case, then did the sun. And so this has been addressed by a number of scientists at the Harvard University in the USA. And they've essentially identified a couple of peculiarities of the outer solar system, which suggests that maybe there was a binary, the sun was part of a binary system when it was born. Now, before you imagine the sun looking like, something from Star Wars, so that you've got two suns rising in the sky and setting in the evening, this second sun that we might have had in the distant past, the suggestion is that it was very distant, 150 billion kilometers away, so far away that it actually would be a pinpoint of light, like a very bright star, not something, like a second sun. And that distance in itself tells you that it might not have been bound very closely to our sun, so that, if something came along, another passing star, for example, with a bit more gravitational attraction, it could have easily pulled it away, because 150 billion kilometers is a long way off. So why do these scientists from Harvard think that there is evidence in the outer solar system that we might once have had this companion star? And one of them is what we've just been talking about, Andrew, the idea of Planet 9. Now, they are assuming that Planet 9 will be found. So this bit of work and this part of the work makes the assumption that Planet 9 is really there. They've got more evidence than just that, which I'll come to in a minute. But if Planet 9 is found, it turns out that it's very difficult to explain its presence, particularly its elongated orbit, without there having been a binary star companion. In other words, if you find Planet 9, then that's relatively strong evidence that the sun was once part of a binary system. You and I have spoken recently about the idea that some scientists are thinking Planet 9 probably isn't there because they've reanalyzed the distant Kuiper Belt objects whose elongated orbits seem to align, which is the main reason why people like Mike Brown, who's one of the principal advocates for Planet 9, he's at Caltech, that's what they've pointed to for the suggestion that Planet 9 is there. Some other astronomers have said these alignments are not real. When you do the statistical analysis, there isn't an alignment of outer solar system objects, so Planet 9 isn't there. So that's one that is still in the mix. And no doubt you and I will go on to talk about this for decades and bore our listeners to death with the idea that Planet 9 may or may not be there until it's found, and then that will sort out the answer. So
that's the quandary, isn't it? If it's found, yay. If it's not found, we're going to keep looking for it.
Yeah, exactly. until the evidence for it disappears, but I don't think it has done yet. I'm a bit enthusiastic about Planet Nine. I think it will turn up one day and surprise us all. And that means then that you've got good evidence that maybe there was a binary companion to the Sun. The other evidence, though, is something that we do know is there, and that is the Oort cloud. This cloud of cometary debris. Really, it's a spherical shell at a very high distance from the center of the solar system, way beyond the icy asteroids that we call the Kuiper Belt. And it's basically this sort of shell of icy objects, some of which occasionally fall into the inner solar system, and we see them as comets. It's that reservoir, if you like, of cometary debris proposed by Jan Oort about the time of the Second World War. I think in the 50s was when he proposed that idea. And it's a very, very convincing explanation for why we see comets coming into the inner solar system at all angles. They don't just come in the plane of the solar system. And basically, the ideas that we have, the theories that we have for how solar systems are formed, say that you should get this phenomenon. You should get a shell of really icy objects way out in the depths of the solar system that is spherical rather than flat like the inner solar system. So we know the Oort cloud exists, but it turns out that it is rather difficult to explain its stability unless there was this second sun in the solar system. So that is the evidence that the scientists point to, principal evidence as well as Planet Nine, that it's why we have an Oort cloud. They are suggesting that for the first 100 million or so years of the solar system's existence, which is actually a very small part of it, bearing in mind that it's 4.6 billion years old, that that's when that companion star was lost, because that early in the solar system's history, it would still be in the star forming region, the cloud of gas and dust that it was formed in. And so what you've got is a lot of other nearby stars which at that distance, as I mentioned earlier, could pull it away, because there's such a dense, such a high density within that star-forming region. So that's where this sits at the moment. There's an interesting paper on this, which is in the Astrophysical Journal Letters, one of the leading journals in astronomy. So it's not, not a fly-by-night idea coming from a bunch of crooks like you and me. It's actually coming from a reputable university, and it's in a reputable journal.
I personally hope there is a Planet Nine and we do find it.
So do I.
Be a pretty exciting discovery, and hopefully they'll find it soon. You talked about the Oort cloud and how it might have existed because of a binary star system, as you discussed. Does that suggest that other solar systems don't have Oort clouds?
That's right, and that's something we really don't know about. The Oort clouds are essentially invisible. Unlike rogue planets or orphan planets, they don't have any heat sources of their own. They're cold, they're icy, they're small enough that you don't really have any nuclear decay of uranium or anything like that. So they're very, very difficult to detect. And so, the possibility is that there may be an Oort cloud around every star, but we just haven't got the wherewithal to observe it. On the other hand, as you say, if you only get an Oort cloud if you've got a star forming as a binary pair, then they might be rarer, although binary stars, as I said at the beginning, are still thought to be actually in the majority in sun-like stars.
Yeah. I suppose, like me, a lot of people think when you've got binary stars, it is like that amazing scene they created in Star Wars with two big suns rising. But as you suggested, they don't have to be close to be together to be binaries. So There's a lot more variation in the definition of a binary than people might think.
Yeah, exactly. So what that's telling you is that gravity works over very long distances, and you can have things that are a really long way apart, but are still gravitationally bound to each other. One is going around the other.
Yeah, very interesting. All right. You are listening to the Space Nuts podcast. Andrew Dunkley here with Fred Watson.
Roger, you're loud and clear here also.
Space Nuts.
Now, if you would like to ask us a question, we've decided we're never going to do that again, so forget it. Or you can send us the question any way you like. One of the ways you can send us a question is to go to our website, spacenutspodcast.com, click on the AMA link, and you will find a record button. And if you've got a device with a microphone, and that can include a smart device or a laptop computer or something along those lines, just press record, say, "Hi, I'm Fred, and I want to know if such and such." It's as simple as that, and then you can just it will download the question to our database, and we will have it instantly. It's really that simple. Or you can do it the old-fashioned way and send it via email. Who would have thunk that in 2020, referring to email as the old-fashioned way of sending us a question would be a thing? But there it is. But, we love your questions, and please send them in. Now, Fred, we do have a question from Paul in Sunshine, Victoria. And thank you, Paul, for sending us your question. I've often wondered why we haven't sent any spacecraft to Uranus and Neptune since Voyager 2. I understand that the Voyager probes took advantage of Jupiter and Saturn aligning with them, and that we still need gravitational assistance from Jupiter. However, surely every 12 years or so, Jupiter will be in a good position to help a spacecraft get to the gas giants. There's still so much to learn about these two planets and their moons that surely there is the opportunity, and we will explore these mysterious worlds further. Love the show. Thanks and regards, Paul. He brings up a very good point. We've done Saturn, and we've done Jupiter, and we've done Mars, and we've done Venus, and we've even done Mercury. But Neptune and Uranus seem to sort of be the second cousins twice removed when it comes to exploration. Is there any particular reason why we haven't gone back? They're just boring, not interesting, or something?
Well, they are interesting, and as Paul mentions, they're ice giants. They may have an icy core.
Right.
They've got a gassy envelope. We often call them gas giants, but they have a different structure from Jupiter and Saturn, which are genuine gas giants. And they're ice giants because they're further out in the solar system. They're in a colder regime of space. They are interesting. They've got, Uranus on its side obviously had some kind of traumatic experience early in the solar system that tipped its rotation over by more than 90 degrees. Both of these worlds have large retinues of satellites, some of which are quite large ones. There is certainly many people within the planetary science community would love to see return missions to either one or the other or both of them. You've got to have them aligned properly before you can cover both simultaneously, and that now is not possible for lots of years until they realign again. But I think the bottom line is that those voices of people who would love to send missions back to those planets, they're kind of overwhelmed by the science that in some ways is more exciting, more immediate, because the bottom line is that there is only a limited bucket of funding that you can draw on to do this. If we had infinite funding for NASA, for example, that would have happened already. But there is such competition for space missions, and it is not a cutthroat business, but it is a really difficult job to get your project above the horizon, even to get it to the starting line. And you and I have spoken before about missions which have, got to the stage where a feasibility study will be done, and that happens, and then you never hear of it again. It's a really tight budgetary consideration. That's what does it at the end of the day. So
it's always money. Money always determines what gets done.
It boils down to. There is, exactly as Paul says, there is so much to learn about these two planets and their moons. We simply have not yet had the wherewithal to do it. I mean, when you think, even about Saturn, which is perhaps, it's certainly among the most interesting planets in the entire solar system because of its ring system. We've sent one mission there. Actually, we've had the Voyagers flying by, but there's only been one dedicated mission to Saturn, and that's Cassini. Look at what we learned from Cassini. It is just a treasure trove of information, not just about Saturn itself, but about the way solar systems form and operate. So really, that's a classic example. Cassini's budget was about, if I remember rightly, about $3 billion, which is a big ticket item in solar system exploration.
Paul makes a very good point, though, because Uranus and Neptune are ice giants, as you said, and we've never sent a dedicated mission to either of them, and yet we have to Pluto, and that's further out, is it not? So how did that happen? And the other, was it just a positional situation at the time?
There was actually a little bit more to it. It's not just fast talking on the part of Alan Stern, the mission scientist for New Horizons, which went to Pluto. With Pluto, Pluto has a very elongated orbit, as you know, and since 1989, I think, it's been getting further and further away from the sun because it's an elongated orbit. And that was felt in the planetary science community to be significant because people thought if it's got any atmosphere at all, it's going to freeze out as it gets further and further away from the sun. So there was an urgency to actually observe it, as soon as possible. And that's also why New Horizons was the Lamborghini of spacecraft. It was one of the fastest missions ever launched, got there within 9 years, in fact, out to the distant solar system. It was done on the cheap, but it was astoundingly successful. That was why New Horizons got up, whereas a Uranus and Neptune mission wouldn't. They're in much more circular orbits.
Okay, so it was a case of we've got to go, and if we're going to go, we've got to go now, and we can always do the others later.
Yeah, that was it.
Pretty simple. All right, there you go, Paul. Never say never, but not at the moment, I think. You're listening to Space Nuts, Andrew Dunkley and Fred Watson. We don't have another question, Fred, but we are going to visit my old buddy, the Space Doogie, which is back in the news. Now, the Space Doogie, or Oumuamua, which was is a cigar-shaped asteroid that didn't actually come from our part of the world. It sort of was just passing through from another place, is back in the news. And at one stage they were suggesting, it could be an alien spaceship. Well, that looks like it's being revisited as well. Why is it in the news again, Fred? Because the theory that really I think a lot of people like the idea of, and we talked about this, that Oumuamua, remember, as you said, it's shaped like a cigar, something like 400 meters long, visited from another solar system, passed at high velocity through our solar system, and is now off into the wide blue yonder. The theory that we discussed most recently was that it was a hydrogen iceberg, something that had come from the center of a giant molecular cloud made of solid hydrogen. And it was the hydrogen outgassing under the heat of the sun that caused the thrust that actually made this object behave in an unusual way, because that was why the alien theory came up in the first place, that something is outgassing from Oumuamua, causing it to stray from its gravitational path,
but it's not shown any evidence of cometary activity. But the hydrogen iceberg theory fit that bill well. Why is it in the news again? Because some of the diehards of the alien theory, and it's principally Avi Loeb, who's the head of the Harvard Smithsonian Institution for Astrophysics. Avi is always provocative in looking for other possibilities. He and one of his colleagues have looked at the idea of molecular hydrogen, the thing being a hydrogen iceberg, and they've said it doesn't work, that actually you don't get these things lasting long enough in order to survive journeys through interstellar space. And so they're back to the idea of it being an alien spacecraft. Nobody believes them, but it's, very provocative, and it is very nice to see it challenged in a sense. So
let me get this straight in layman's terms. The theory that it's a hydrogen iceberg is being dismissed by them because the distances that it's had to travel to pass through our solar system were too great for it to survive the journey as a hydrogen iceberg, so therefore it must be an alien spaceship.
That is right.
That's a long bow.
It's a long bow. It is a very, very.
I like it. I like it a lot. It's a long bow.
Yeah. Avi Loeb has a book coming out, which it's not yet released, but it's coming out, and it apparently will be called Extraterrestrial: The First Sign of Intelligent Life Beyond Earth. We'll see it in January. So there you go. So this might just be, a bit of a publicity stunt for his new book.
Who would dare suggest that, Fred?
Me. You've written books. You know how to do it.
Good luck to him. Wouldn't it be great if he turned out to be right? I think that would be amazing. And as you and I often say, you just can't write off anything when it comes to space and other stuff and astronomy and science. There's so many unknowns, so why the heck not? So, can't wait to see his book. Oh, speaking of which, Fred, I have finished recording the Turanian Enigma in audio format.
Oh, that's great. Oh, that's something to download.
Oh, boy. That's such hard work.
Yeah.
Yeah, it's very hard work. The editing is a nightmare, but it's done. It's about a 5 to 6 hour audio experience. It's not available yet. It's going through the ringer with the publisher. Uh-huh. And once if it passes muster, and that's the big if, and I won't know until next month, I think, it will be available through just about every audio book outlet available.
Fantastic. That's brilliant.
Online. So,
yeah, excellent.
And it's a bit of an experiment because it's a bit of a strange one because there aren't too many avenues of opportunity for Australian authors to upload audiobooks without having to pay a mozza. And I certainly didn't want to do that. So I found a way around it through a third party. And the irony is the avenues that I wanted to use that aren't available in Australia are available through the third party. So
there you go. There's Gregory.
There he is.
Yeah.
Gregory's happy. I'm glad Gregory's happy, and I'm glad he made an appearance. But anyway, I'll let you know because I've had quite a few people ask if they can get an audio copy, and we're nearly there. I'm just it's going through quality control at the moment, which is pretty scary. But anyway, we'll see how that turns out. And that wraps us up for yet another week. Fred, thank you.
Great pleasure, Andrew. Always good to talk, and I look forward to talking again.
Yes, indeed. Well, if there's no talking, there's long periods of silence, and that's, that's a bit of a scary situation. Good to talk to you, Fred. Catch you soon. Fred Watson, Astronomer-at-Large, part of the team here on the Space Nuts podcast. And from me, Andrew Dunkley, thank you again. We look forward to your company next time on another edition of Space Nuts.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.